In this section, we're going to review all the types of factoring that we've done so far in this chapter by factoring a variety of problems. Here I've written x squared minus 81. This looks like the difference of two squares, so I'm going to factor it as x plus 9, x minus 9. And then remember, with factoring, I can always multiply these back out and see that I get what I started with. X plus 9 times x minus 9 will give me exactly x squared minus 81. Next problem. Y squared minus 10y plus 25. This looks like, how about y minus 5 quantity squared, or y minus 5 times y minus 5, either way you want to write it. Y times y is y squared, negative 5 times negative 5, positive 25. Inside minus 5y, outside another minus 5y. Sure enough, those add up to minus 10y. So these are the factors, y minus 5 and y minus 5, or if you want, y minus 5 quantity squared for the factorization of this. xy minus 5x plus 2y minus 10 looks like a factoring by grouping problem because it's got four terms. Let's factor an x out of the first two. What's left is y minus 5. Let's factor a 2 out of the second two. What's left is y minus 5. I'll take this y minus 5, factor it from each term. What's left in the first term when I factor it out is x, plus what's left in the second term when I factor out y minus 5 is 2. So y minus 5 times x plus 2, if I multiply these two binomials together, I get exactly this polynomial right here with the four terms. So you see, I'm just factoring a variety of polynomials, and looking at each of the factorizations comes from one of the sections that we've covered so far. How about 3x squared plus 15xy plus 18y squared? Do you see that there's a 3 common to each term? I'll factor it outside. What's left is x squared plus 5xy plus 6y squared. So that is one of the factors, so I need to write it down. Let's factor the trinomial that remains with an x and an x. Then I want to multiply and get 6y squared and add and get 5xy. I think 2y and 3y will do it. Inside 2xy, outside 3xy, those add up to 5xy, and 2y times 3y is 6y squared. So that is the factorization for this. Remember, you always want to factor out the greatest common factor first if it's any number other than 1. Fifth problem right here, 49x squared plus 9y squared. No greatest common factor other than the number 1. This is a perfect square, this is a perfect square, but this is addition. Does not factor further. Although the difference of two squares always factors, like problem number 1 that we did, the sum of two squares does not factor any further than that. So you can't find two binomials to write down to multiply that will multiply and give you 49x squared plus 9y squared. Here's our last problem. 6a squared minus 1ab minus 15b squared. We'll just do a little trial and error here. How about 3a and 2a to multiply and give me 6a squared? 15b squared, what if I put 5 and 3? 5b and 3b. Inside would be 10ab, outside would be 9ab. Those do differ by 1ab. I want this to be negative, so I'll make my 10ab the negative one and the other one positive. Now if I multiply negative 5b times positive 3b, I do get negative 15b squared. So there we stumbled on that right to begin with our trial and error method. The factorization for this trinomial right here is the product of these two binomials.